In the present lecture, we will discuss the overview of the strength of material subject and also discuss the mechanical properties of materials. First, let's see the term strength. So, in general, strength refers to the any person lifting or holding the high weights. We are calling as the person having the high strength. Similarly, for the materials point of view, strength refers to the ability of an object or material to withstand for applied force, pressure or stress without breaking, deforming or failing. For a body or material, physical strength refers to the resist the mechanical loads such as tension, compression or bending. And for a structural member, structural strength refers to a load bearing ability. So next we have to see the term materials. So we have to discuss the classification of materials in the terms of nature of deformation. First material is the elastic material. So elastic materials undergoes a deformation when subjected to external loading. Such deformation disappears on the removal of the loading. So in elastic material, deformation due to the applied load disappears after removal of the loads. Let's see, the example is the rubber band. If you apply the load, it will be stretched, and removal the load, it comes to the original shape. So these kind of material we are calling as the elastic material. So next we have to see the second material is the plastic material. Plastic material undergoes a continuous deformation during the period of loading, and this deformation is permanent and material does not regain its original dimension, is called as the plastic material. So for example, aluminum rod, if we applied the load, it will be elongate, and then if we removing the load, it does not come back to its original dimensions. So these kind of material we are calling as the plastic materials. Next, third type of the material is the rigid material. So rigid material, so it does not undergo any deformation when subjected to external loading. So examples are the stone is best example for the rigid material. Okay, we discussed the two terms, strength and material. Now we will look for the strength of materials. So strength of materials is a subject which study of internal effects and deformations that are caused by the applied loads. And we know that engineering mechanics is broadly classified into three areas, that is the statics, dynamics and strength of materials. In statics and dynamics, we study the behavior of rigid material in the terms of reaction forces, displacement and moments when applied the load. And in the strength of materials, so we are studying the how the solid bodies react when subject to various types of loading. And here we are consider the solid bodies like the bars loaded longitudinally, and beams subjected to bending, and shaft subjected to torsion. So overall objective of the strength of materials is, here we have to determine the stresses, strains, deformation in several structural members under the action of the several loads. So overall in this subject, we will discuss the following topics. So that is, the first one is the simple stresses and strain, and strain energy, and shear forces and bending moments, stresses in beams, direct and bending stresses, deflection of the beams, torsion of the shaft, principal stresses and strain, thick cylinders and spear, thin cylinders and spears, column and strut. So these are the overall we have to discuss in the strength of material subject. And before going to the strength of material subject, so let's see the mechanical properties of the materials. First mechanical property is the elasticity. When external forces are applied on a body, these external forces try to deform the body, but the forces between its molecule try to stop this deformation. So the deformation or displacement of the particles continues till full resistance to the external forces. If the forces are now gradually removed, the body will return to its original shape. So elasticity is the property of a material which undergoes a deformation on the application of a loading such that the deformation disappears on the removal of loading. So best example is the rubber band. So when applied the forces, it will be stretch, and after the removal of the loads, it will come back to its original shape and dimensions. So this property we are calling as the elasticity. So if a body completely regain its original shape, it is said to be perfectly elastic material. For every material, regaining its previous shape and size is exhibited on the removal of the loading when intensity of the stress within a certain limit is called the elastic material. So every material having this elastic property up to the certain limit. So when we are applying the forces exceeding this elastic limit, then material undergo to the plastic state. So next we have to look for the second property is plasticity. A material in a plastic state is permanently deformed by the application of load, and it has no tendency to recover. So when you applied the load, so material will go to the deformation, so which means it's changes dimensions and shape. After removal of the load, it does not come back to its original shape and dimensions. So this we are calling as the plasticity. Every elastic material possesses the property of plasticity. Under the action of large forces, most of the engineering materials become plastic and behave in a similar to a viscous liquid. When large deformations occur in a ductile material loaded in a plastic region, the material is said to undergo plastic flow. So if a ductile materials, we'll discuss later what do you mean by ductile materials. If any ductile materials loaded in the plastic region, so it will go the large deformation, that is we are calling as the material in the plastic flow. Plasticity property is particularly useful in the operations of pressing and forging. So this is the very important. So in general in the competitive exams it will be asked. So which property is useful in the pressing or forging operations? So answer is the plasticity property. So next we have to see the third property, ductility. Ductility is the characteristic which permit a material to be drawn longitudinally to a reduced section under the action of tensile force. In a ductile material, therefore large deformation is possible before the failure or rupture takes place. A ductile material must of necessity possess a high degree of plasticity and strength. Ductility is measured in the tensile test of specimen of the material, either in the terms of percentage of elongation or in the terms of percentage of reduction in the cross section area of the test specimen. So the property of ductility is utilized in wire drawing operation. So this is the very important for the competitive exam point of view. So the ductility property is utilizing in the wire drawing operation. So you see here, so this is the wire drawing operation. Here we are reducing the cross section of a bar by applying the tensile forces which is passing through the die. So here required property is the ductility property is required for the material. Next property is the brittleness. Brittleness implies lack of ductility. So the material which not having the ductility property we are calling as the brittleness, which means which is not possible for the large deformation under the load. A material is said to be brittle when it cannot be drawn out by tension to smaller section. So brittleness means the material which is not possess the large deformations under the tensile forces. So the best example is the glass material. In a brittle material, failure takes place under the load without significant deformation. So brittle materials it will be failed. Suddenly it will not give the any deformations, any indications it will be not give for the failure. So in brittle material, failure takes place under the load without significant deformation. So glass is brittle material because it breaks quickly when struck without bending. So brittle fractures takes place without warning and property is generally undesirable. See the pictures below here it is given, the one is the brittle fracture and second one is the ductile fracture. So observe in the brittle fracture, so it is the break the material without giving the any indication. But see here ductile fracture, so before going to the failure, so large deformation is occur. So it is given the proper indications before the failure. So examples for the brittle materials is the cast iron, high carbon steel, concrete, stone, glass, ceramic materials and many common metallic alloys. Next property is the malleability. Malleability is the ability of a material to be hammered or rolled into thin sheets without breaking. So malleability is the property of material when it undergoes a thin sheet by applying the compressive forces with hammering or maybe rolling. So in malleability, compressive forces are applied to a material. So chapati making is a good example of malleability. So here we are applying the compressive forces, then this atta it will be spread in all the direction and it will be making so thin chapati. So a malleable material possesses a high degree of plasticity but not necessarily a good strength. So this property is utilized in many operations such as forging, hot rolling and drop stamping. So this is the very important for the competitive exam point of view. So malleability property is utilized in the operations of forging, rolling and drop stamping. So next property is the toughness. Toughness is the property which enable it to absorb energy without fracture. So which means it shows how much energy of a material can take before it fractures. So this property is very desirable in component subjected to the cyclic or shock loading. The best example is the car bumper. So when a car hits something, the bumper absorbs the impact energy without cracking easily. So which will helps to protect the rest of the car. So this shows the bumper material has high toughness. Toughness is measured in the terms of energy required per unit volume of the material to cause rupture under the action of gradually increasing tensile load. So next property is the hardness. Hardness is the ability of material to resist indentation or surface abrasion. So in general, so test on hardness may be classified into the two tests. One is the scratch test, second one is the indentation test. Next property is the strength. The strength of material enables it to resist fracture under the load. The required to cause fracture divided by the area of the test specimen is termed as the ultimate strength of material. So this is we will discuss later in the stress strain diagram. What do you mean by ultimate strength? And strength is expressed in the unit of stress. So these are the important properties of the material, and thank you.